In today's video, we will learn how to create a Spring Boot application with complete REST API that supports database CRUD operations using Spring Data JPA. You will learn a lot if you are not familiar with the concepts, but even if you are, you will definitely learn something new. We will be creating a REST application around objects of type post having a title and description. You will be able to add new post, update existing post, fetch list of posts and a single post by its ID and title, and delete posts using simple REST API calls. Let's get started. We are using Spring Tool Suite or STS, which provides a direct option to create Spring project. If you do not use STS, then I have also covered how to create a Spring project using Spring Initializr. Go to File menu and click on Other. Select Spring Starter Project. If you don't find this option directly here, then type Spring in search box. Click Next. Provide a name of project. We will be using Gradle as build tool. Packaging will be of type jar. Language will be Java. Java version is 17. Though you can use older or newer versions as well, doesn't matter. Provide a group ID and artifact ID. Provide a description and a package name. Click Next. On this page, we will choose the required dependencies. We will need Spring Data JPA, Web dependency since we are creating a REST application, MySQL because we will be interacting with MySQL database. That is all. Click Next and finish. This will download all the selected dependencies and create a project for us. The project is ready. Open it and select build.gradle. Here are all the dependencies that we selected. It also creates a main class having main method. Second way to create a Spring Boot application is with Spring Initializr. Open a web browser and go to start.spring.io. This contains the same set of options that we saw in STS, such as name of project, language, build tool, Spring Boot version, group, artifact, etc. Click on Add Dependencies on the left side, search for JPA, Web, and MySQL and select these. When you click Generate, it will download a zip file which you can directly import into an IDE of your choice. Next, let's create a database to which our application will connect and insert records. Open MySQL Workbench or any other database client that you are familiar with. Right-click and create a new schema. Name it PostDB. Click Apply, again Apply, and finish. Now go to the project and open application.properties under src/main/resources folder. Here we will provide configuration properties so that our application is able to connect to the database that we just created. First property is spring.datasource.url. Its value will be jdbc :mysql :/localhost since our database is running on local system :port at which MySQL service is running, which is 3306 /database schema name, which is post. Second property is spring.datasource.username, whose value will be the user with which database connection will be created. Third is the database password. Fourth property is database driver class name, which is com.mysql.cj.jdbc.driver. Next, provide spring.jpa.hibernate.ddl auto property and set it to update. This is only required when you want the database tables to be automatically created and updated according to the entity classes that are present in the application. If you create the tables manually, then don't add this property. Finally, spring.jpa.sql and set it to true. This is also an optional property which is only required when you want to print the database queries executed by your application for debugging purposes. Now we will look at creating the classes and interfaces required for creating REST API application. Create a new class. As a standard, we should place it in a package. Name it entity. Class name will be post. Annotate it with entity annotation to mark it as an entity. This class represents a table in database and all its fields represent the column of that table. Notice the package name of entity. It starts with Jakarta. In most of the videos, you will see it as JavaX. This is because we are using Spring Boot version greater than 3.0, starting which JavaX packages have been changed to Jakarta. If you will use a version below 3.0, you will get JavaX package only. So, don't get confused if you see JavaX packages in other videos or blogs. This is only because they are using an older Spring Boot version. Next, create an ID field. Annotate it with ID annotation, which specifies that the database column corresponding to this field will be the primary key. Also provide generated value annotation over it to specify that its value will be auto-generated. Next, create other fields such as title and description. By default, the database column names should be with the same name as the name of fields. If the column names in database are different than the field names, then you can specify them using column annotation. The name attribute is the actual column name in database table. Generate getter and setter methods. The name of database table to which this entity will be mapped can be specified using table annotation followed by the table name. Start the application. The application has started and look at the logs. It has created a database table for the entity class. Let's verify. Go to MySQL Workbench. Expand the tables. We have a table named Post. Check its column names. They are the same as the fields that we defined in entity class. Now create a repository, which is responsible for interacting with the database. Create it in a separate package. A Spring Data repository is an interface. It should extend JPA repository, which is an interface provided by Spring Data. It has two generic types. First is the type of entity. Since we are creating this repository for post entity, this will be post. Second argument is the type of primary key. It will be integer, and this is because we define the primary key in post entity as integer. We can also make it long if your table will have a large set of records, but it will be integer in this case. Finally, to make it a Spring Managed Bean, provide a repository annotation over it. Next step is to create a service which contains the actual business logic and interacts with the repository. To interact with the repository, it needs access to its object. We can simply inject the repository using Spring AutoAdd annotation. Now, we will create methods to save, update, delete, and fetch a post from database. So, first define a method to create a new post. This method will get a post object containing the values that are sent by the client such as a browser, postman, etc. Save it to database using repository.save method. Next, create a method to update an existing post. This will also accept a post object as argument. The only difference between the post object in create and update methods is that the object in update will contain an ID. For updating an existing post, first we need to fetch it from database using its ID. This ID is present inside the object that was sent for updation. So, fetch the object using findById method. You can see that it provides multiple findBy methods so that you can find an object in multiple ways. All find methods from Spring Data JPA repository return an optional object that wraps the actual object. We can check if the optional contains an object using its isPresent method. In the else part, you can handle the condition when object with this ID is not present in the database by throwing exception or returning error message. The object wrapped by optional is retrieved with its get method. Assign it to a new variable. Now, we need to copy the values from the incoming object into the object from DB since we need to persist the incoming values. Finally, call save method on repository. You must be thinking that how can we use save method for persisting a new object and updating an existing one? Spring Data JPA is smart enough to figure out the difference, and it does this on the basis of ID value, which is null for save operation and non-null for update. Next, create a method to delete a post. This method will accept the ID of post. Call delete method on repository. You can see that there are multiple delete methods where we can delete using ID or fetch an object and then pass this object to delete, and we can also delete all objects in one go using delete all method. Here we will be using delete by ID method. Define a method to fetch a post using its ID. There is an inbuilt method in repository called findById. This also returns an optional as explained earlier. Here we will assume that the optional contains an object, so we will directly call get and return it. Next, create a method to return all posts. This method will return a collection, which will be a list of post objects. Simply call findAll, which returns the list of objects. Finally, we will look at the method to fetch an object based on one of its fields, such as title or description. Spring repository has only predefined method to fetch an object using its ID. It does not contain any inbuilt method to get an object using its fields. The reason is obvious, since it does not know what fields the object will contain. ID will always be present. So, if you want to fetch an object using its field, then you need to declare a method in repository with a specified syntax. It should begin with findBy, followed by the name of field using which we want to fetch the object. In this case, it is title. It will accept a string argument, which will be the title value, and its return type will be a post, since there will be only one post with the title. If there may be multiple records having same title, then change the return type of this method to a list, and Spring Data JPA will automatically return a list of objects. You can also fetch using multiple fields using AND, such as find by title and description, etc. Besides this, you can even fetch data based on comparison of field values such as equal, greater than or lesser than, date comparisons, etc. Here is a comprehensive list of ways in which you can define repository methods. These are the corresponding database or SQL expressions. This is the power of Spring Data JPA, where simply by declaring a method, you get its functionality. Now, let's create a method in service to fetch records on the basis of title. This method will return a post object and accept a string argument, which is the title of post. Call findByTitle method on repository and return it. Add service annotation over this class to make it a Spring managed bean. Next, create a controller. Create a new class in controller package. Name it postController. To mark a class as Spring Controller, annotate it with REST-controller annotation. Also define a URL mapping at which its methods will be accessible. This means that all the methods of this class will be accessible under post URL after the context path. This class will call the methods of service class. So, inject a service using AutoAdd annotation. Now we will define all the methods corresponding to the methods in service class. The methods that we will define in controller class will be accessible over URLs exposed from the application using Spring Boot annotation such as get mapping, post mapping, etc., which correspond to HTTP get post methods, etc. First, create a method to create a new post. Since this method is creating something, it will be a post request. Hence, its URL mapping would be of type post mapping. Next, it will take an object of type post. Since we need its fields to be auto-populated with the keys of incoming request, we need to annotate it with request body annotation. This method should return a post object, which is the newly created object saved to the database. In real applications, we should not directly return this object, but a response entity object which contains a status code, message, and the data that we need to send back. For learning purpose, it is fine. Here we will call createPost method from service class. There is a compiler error. This is because our service method is not returning any value. Let's change the service method to return this object. Next is the method to update the post object. A method that updates something on the server indicates an HTTP put request, and so it should have a put mapping annotation. We will be returning a string from this method, which is simply a success message. This method will accept an argument of type post and should have request body annotation as in create method. Call the service class method to update post and return a success message. Next is the method to fetch a post. Since this method is fetching some data and giving it back to the client, it will be an HTTP GET request and it should have a get mapping annotation. Return type will be a post object. This method should accept an integer argument, which will be the ID of post that we need to fetch. Now, the question is, how will this argument get its value? Here comes another concept called path variable. Path variables are the values placed after the URL mapping. In Spring Boot, we define a path variable in URL mapping using curly braces. To link a method argument with this path variable, we place a path variable annotation before it and provide the same name as in the URL mapping. This is also required because there might be multiple path variables in a single mapping, and to link them with corresponding parameters using path variable annotation. So, this method will be called when someone accesses a URL of type /post/1, where 1 will be the ID of post. We will simply call the service method that fetches a post using its ID. Next is a method to delete a post using its ID. The URL mapping will be a delete mapping since we are deleting a resource. Return type will be a string representing a success message. This will accept an integer which will be the ID of post. We also need to add a path variable in the URL mapping to get the ID of post being deleted directly from the URL. Call the service method to delete post and return success message. Next is the method to get all post. It will also be a get mapping since we are fetching some data. The return type should be a list of post objects. Call the corresponding service method and return its result. Finally, we will create a method to fetch a post using its title. This will accept a string argument which will be the title of post that we want to get. It will also be a get mapping, and now you should be knowing why. The title we will get directly from URL using path variable. Add path variable annotation before the argument. Remember that if the name of path variable in URL mapping and method argument name are same, then it is not necessary to provide a string after path variable annotation. It will automatically infer the argument to be mapped. Now there's a problem here. Both these methods will be mapped to a URL /post/something. This something might be an ID or a title. This problem will arise when we try to access either of these URLs, and I'll show you the problem and its solution at that time only. So we have all the REST endpoints ready, and there is a manual error that I have deliberately done in one of the methods. Pause the video for a second, and if you figure out, write it in the comments below. Have you caught the mistake? As a hint, it is in the delete post method. Okay, so we have missed the path variable annotation over the method argument. Without this, you will get the ID as null since we are not telling Spring to bind it to the variable in the URL mapping. Open Postman. Define a new request to create a post. Enter URL http localhost since the application is running on local system :8080, which is the port at which it is running, / the URL of method, which will be post. Provide the body to be sent in request. Select JSON format since we will be sending a JSON payload in request. Request body will have two keys, title and description. The type of request will be post. Send. Look, we got the response, and in response we also got the ID of newly created post. If we look at the console logs of application, look, it has inserted a record in post table. Let's also verify in the database. Go to MySQL Workbench. Select records from post table. We have one record inserted. Now let's change the values and create another post. Create a third post. Let's fetch all the posts. Simply change the method type to get. Look, we got 3 posts. Now let's update a post. Change its description and change the method type to put since we are updating a record. We got a success message. Again, fetch all the posts to check if the last post was updated or not. It is updated. Next, test the delete method. Provide the ID of post to be deleted after /. Change the method type to delete. Send request. We got success message. Fetch all posts again. We got only 2 posts, which means that the third post is deleted. Now fetch a single post using its ID. This API call will not succeed but result in an error, as I said earlier while designing the APIs. Look, we have a server error. The reason is that both these methods that fetch by ID and title have the same URL mappings. If you look at the error message, it also says ambiguous handler methods mapped. When a request arrives, it is not able to figure out which method to call, since a URL post/1 will match both these methods. A solution for this is to change the URL for the method that fetches the post by its title by adding title before the URL. This will make the URL for this method as /post/title followed by the value as path variable. Restart the application. Back to Postman. It's working. Change the URL followed by the title of the post. This also works. There is one more way to pass a value from URL other than using path variable, which is using request parameter. A request parameter is supplied in the form of key value pair after the URL, such as, in this example, value is the key with which we fetch the actual parameter value in the handler method. So we don't need this path variable anymore. And to get the value of a request parameter, Spring provides a request param annotation followed by the name of parameter. If the URL contains a request parameter with this name, its value is automatically populated into the method argument with request param annotation. Restart the application. Go to Postman and change the URL by adding request parameter. It works. So we are able to fetch a post using its title as well as ID. So we have seen how to create a REST application with complete CRUD operations using Spring Data JPA and MySQL. Hope the video was useful. Thanks for watching.